Okay, so good morning, everyone. Welcome to this introductory webinar organized in the framework of the GIS School project. My name is Elisa Filippi, and I work as a co-founder and a project manager for Euroniche, which is this association based in Italy, and also the coordinator of the GIS School project, together with you and all the 10 partners. It's really a pleasure to meet you today for the first time, some of you, even if just virtually. But it's really a pleasure to have this common meeting, common opportunity of training with all the 4 secondary schools participating here today. So welcome, and I wish you really an interesting morning with this webinar. As you know, the webinar has been organized by Politecnico of Milan, that very soon will introduce you to the agenda and to the concept of this webinar. For our side, I would just to remind you that this message is in particular addressed to the pupils. During the morning, just before the coffee break, you will receive a message on your Telegram notification with a survey to fill in. This survey will take you just 2 or 3 minutes, so it is very you can answer and respond to the survey in very soon. So we invite you to keep an eye on your smartphone and on your Telegram just for the coffee break, so not during the lessons, but for the coffee break, yes. And we really invite you to fill in and to answer to the survey, because it is extremely important for us in order to monitor your training path and to monitor and assess and evaluate the impact of the project on your learning path. So I would like to say thank you again to you, and I will just leave the floor now to the professor of Politecnico for introduce you to this webinar.
Thank you, Lisa, and welcome to this webinar entitled Climate Change and Natural Results, Some Practical Examples. My name is Marco Gianinetto from Politecnico di Milano, and you can see connected also my colleagues Maria Brovelli and Daniela Carion. So welcome to everybody. Today we have connected students of Escola Secundaria Dr. José Alfonso from Portugal, ITT Marconi from Italy, Colegiul Nacional Ion Neculce Bucharesti from Romania, and yes, Marc Ferrer from Formentera, Spain. So welcome to all you guys. This webinar aims to inspire you to find data, information, maps, and indicators, and combine them with satellite imagery and other valuable data and information into simple geospatial analysis on the climate-related issues you are interested in. Today, we will have a masterclass where 4 experts of geoinformation and Earth observation will give you a lecture on all the topics chosen by your school. Just to remember that Scuola Secondaria José Alfonso expressed interest in flooding, ITT Marconi expressed interest in forestry applications, Colegiul Nacional Ion Neculce Bucharesti expressed interest in air quality monitoring, and yes, Marc Ferrer expressed interest in monitoring the marine ecosystem of our beautiful island. So therefore, the masterclass will show examples, case studies, simple analysis, or small manipulation of data and cited images that could give you some ideas or inspiration for your own project. Next, there will be a live session where you guys can ask any question to our experts. But why should you care about GIS, satellites, and monitoring from space? So far, you have lived without that. And last week, I attended the Romanian Multiplayer event and recalled how over the next decade, the European Union will invest 30% of its budget in action against climate change to make Europe the first continent with zero net climate impact by 2050. And this is what is called the European Green Deal. And we are talking about 4 billion euros. So that's an enormous amount of money, really. And to implement its green transformation and to support the sustainable economic growth, the European Union is making the Copernicus Earth Observation Space Program one of the key technologies for its green transformation. And not only to monitor the environment or to evaluate the effects of climate change, but also to bring new services to all European citizens. And this is what is called the new space economy. I know and understand that the year 2050 seems far away, and at that time I will be retired. Hopefully, I will still alive, hopefully, but you guys will be about 45 years old, so in the middle of your professional life. And I suppose that many of you will be working in the green economy. And so geoinformation and maybe also space observation will be part of your everyday work. So now, coming to our program, we have 2 male and 2 female speakers, so a perfect gender balance today. Simone Balbo is our first speaker. Simone, can you please turn on your camera and microphone? Thank you, Simone.
Sure.
He worked
Can you
at,
see me?
yes, thank you. He worked as consultant at the Joint Research Center of Italy, which is, maybe you don't know, but it is the third biggest European Commission site after Brussels, of course, and Luxembourg. And Simone has a background in environmental engineering, and he's a super expert of geoinformatics applied to emergency management, such as GIS technology, geospatial data processing, satellite image analysis, and web mapping. And today, Simone will give a speech on flood risk and damage assessment with the Copernicus Emergency Management Service. Then, Daniele Uxoli. Hi, Daniele, can you please turn on your camera and mic?
Good morning, everyone.
Thank you. This is Daniele. Daniele will give a speech on air quality monitoring with satellite images and geospatial data. Daniele is my colleague at Politecnico di Milano. He has a background in mathematics engineering and is trained in voluntary geographic information, geoinformatics, Earth observation, and spatial statistics. Daniele is also co-founder of a startup that creates geospatial solutions for public and private customers, and therefore Daniele has a deep understanding also of the geospatial market. After a short coffee break, we have a speech by Julia Dananegula. Hi, Julia. I see you already connected. Hey. She's senior researcher at the Romanian Space Agency and also teaches at the University of Agronomic Science and Veterinary Medicine in Bucharest. Julia has a background in engineering sciences and a very long experience in Earth observation. Her research interests are very vast and span from agriculture to cultural heritage, always with a strong focus on environmental problems. So today, Julia will give a speech on the marine ecosystem and its monitoring from space. So thank you, Julia. And finally, Francesca Giannetti. Hi, Francesca. Can you turn on your camera, please? Francesca, can you hear me? Elisa, is Francesca allowed to turn on the camera and the microphone? Can you please check? Giannetti.
She seems to be allowed, Marco.
So it is possible we have some technical problems. So while Elisa is checking Francesca connection, Francesca will give a speech on Earth observation for forestry applications. And let me say a big thank to Francesca for filling in at the last minute for a speaker who had a family problem. So thank you very much, Francesca. Francesca is from the University of Florence, Italy, and is an experienced forestry expert. Her research interests are in the field of forest inventory and precision forestry using different remote sensing technologies such as UAVs, photogrammetry, LiDAR, and optical satellites to detect forest changes and map forest variables at different scale. That's all. Simone, thank you for being with us today. You have already turned on your webcam. You can turn on your microphone, and the stage is yours. Thank you very much.
Thank you very much, everybody. I see there is a huge crowd, so I hope I will be up to the task. And thank you, Marco, for organizing, and to the representative of Politecnico di Milano, Professor Brovelli and Dr. Carion, to hosting me here. I'm very happy to be able to participate. So my speech, but first you gave a very good introduction. So I'm a consultant to the Joint Research Center, and I work in the Disaster Risk Management Unit. Specifically, I follow a service of the European Commission, which is the Copernicus Emergency Management Service. And I will start in my speech from introducing this service, and then I will provide some examples of some of the products that this service can produce. So I will try to share my screen, and maybe I will turn off the camera in order to not overload the bandwidth. So at any moment, if you don't see or if you don't hear me, please interrupt me. So I'm trying to share the screen.
Okay. We can see your presentation, Simone.
Okay, so I'll put it full screen. Okay.
Thank you. I remember all the speakers, they have 13 minutes for their speech.
Okay, so 9:25 should be the end. Okay. Sorry, 10:25. Okay, so again, this is an introductive slide related to, as an introduction as a framework to where I operate every day in the Copernicus Emergency Management Service, and in particular in the Risk and Recovery Mapping Service. Just a brief introduction to the Copernicus Emergency Management Service. I reported here a couple of videos that gives a very good introduction to the Copernicus in general and of the Emergency Management Service in particular. So I will summarize a bit the content, but for the audience, I'm confident that this material will be provided to you, so you can later on look also at these videos that will provide more detailed information about the service itself. In few words, I try to summarize. The Copernicus is the European Union a European Union program coordinated and managed by the European Commission, and the aim is to develop the European information services based on satellite Earth observation and also in situ data. So there are two three main components, let's say. The main component number one is the satellite component. The European Commission runs satellites through ESA. There are several. They are also called the Sentinel missions, and I think you have heard about that in previous webinars. The second main component is the in situ component, which concerns is related to data that are not derived from satellite observation, but from stations on the ground, which can be, for example, buoys on the seas, overseas. The third main component of the Copernicus program are the services. There are 6 main services to monitor different aspects. As you can see, the atmosphere aspect is one, the second is marine, the third is land, then there is climate, then there is security, and last but not least, the service I'm involved in is the emergency management service. The main objective of the emergency management service is to help victims when disaster strikes. This is done by providing timely and rapid information to mainly the civil protection agencies that around Europe, but not only around Europe, because this is a global service, are dealing with emergencies, sudden emergencies, such as floods, earthquakes, etc., etc. This service is operational since 2012. It addresses both natural and also man-made disasters. For example, one example of man-made disaster is the Beirut explosions at the port that occurred in August 2020. This service supports all phases of the disaster management cycle, so preparedness, response, and recovery. So before, during, and after the events. For example, it provides warnings and risk assessment for floods, forest fires, but also information on the impact of natural and man-made disasters. In this picture, you see what we call the emergency management cycle. So from preparedness to emergency response to recovery, these three phases can be seen in a cycle when the event with the event as the trigger to this cycle. In terms of components, so the emergency management service is structured in 3 main components. One component is the early warning, which provides, especially for floods and forest fires, also forecasts or risk assessments on these 2 type of events. And then we have the rapid mapping and risk recovery mapping. The rapid mapping is a mapping service that provides timely information in the early response phase, while the risk recovery has a wider scope, so it can be activated in different phases. Again, the preparedness and the recovery. These are a few examples of these components. So you see on the right the early warning and monitoring system that I mentioned. On the top there is the EFIS, the European Forest Fire Systems. In the center, the European and Global Drought Observatory, and on the bottom, the EFAS, so the European Flood Awareness System. On the left part of this slide, instead, you see the 2 modules related to mapping. I will go in deep on the on-demand mapping services. First of all, they are called on-demand because they don't work continuously, but they are activated on specific request by member states, by European member states. There are a number of authorized users that, one for each country, are entitled to activate the service when a disaster occurs. As said, this is a global service, and this means that also from outside Europe, this service can be activated. And in this case, the authorized users are the European External Action Service, the ECHO field officers, and also UN representatives. In this slide, you will see a few more details related to the two models, the two mapping models that I mentioned. Again, the rapid mapping is 24/7 because it has to work in the emergency response, so rapidly after the event occurred, while on the left, in brown, you have the risk and recovery mapping. In this case, the service work during working hours, so there is more time to develop more structured methodologies and to support, for example, preparedness and recovery activities. As you can see, both services can work with Earth observation data as input, meaning satellite imagery in input, and the risk recovery mapping in particular can also include ingest non-Earth observation data, for example, in the in situ data that I mentioned at the beginning. These two components are supported by a third component, which is the validation, and this component deals with service improvement. So it does technical and qualitative evaluation and user it looks for user feedback in order to improve continuously the service. Within one more step, let's go one more step in deep into the risk recovery mapping in particular. There are two, it is regulated by two main framework contracts. One deal with standard activations, standard products, and the other with complex activations, so with complex products. So with the standard, we have a list of predefined methodologies, predefined products that can be asked and can be generated quite rapidly in terms of days from the request, while for the flex, this takes into account more complex cases. Therefore, it is tailor-made. So, from the request that comes from an authorized user, the response is studied in deep with a specific methodology tailored for the specific case. In this slide, I listed the products that are related to flood, given that this session is specifically dealing with floods. And in the portfolio of the risk recovery mapping standard, we have three main products related to flood. The most simple, starting from the top, we gave number to all of them, but from the top, the product 4 is the flood delineation, which is the simplest of the products. The second product is the model of the flood extent for major events. And then the third product is the temporal analysis of occurred flood events. I will give now a few examples of some of the products that were developed, that were produced with these mentioned methodologies, and so we can have also a hands-on on these products. A few information about the flood delineation product. For risk recovery mapping, we have a limitation in terms of size that we can produce, and this is between 25 and 500 square kilometers. It can generate as an output the flood extent, so the portion of the territory that was flooded, and also the water depth at the moment of flooding. It can deal with both coastal and inland events type. And in terms of input data, the main input data is satellite imagery. It can be usually, as we will see later, it is radar data, so synthetic aperture radar data, but can also be built on top of optical imagery. Another input data is also the digital elevation model, from which we extract the elevation in order to calculate the depth of the water. So a few details about the production time is between 5 and 10 days. And two limitations that we have to mention. In case of optical data, we can have limitations if there are clouds, and this is usually the case in case of flood events because there is heavy rain, so we expect to have clouds, and with optical data is quite rare to be able to get the extent of the flood. And so most often we work with the synthetic aperture radar sensors. And in that case, the technical limitation is related to urban area because for a complex behavior of the beams, then we have quite some noise in the imagery. In terms of methodological, in terms of method, the limitation is that this product represents one only moment in time. And it means that we have the flood extent at just one time, at one just specific time. And this may be not, and most often is not, the peak of the flood. Therefore, what we have in terms of extent is the extent for that specific moment and not the peak extent of the flood. We have an example here now of one of activation that we performed in the past. This is for Cameroon, a flood in Cameroon. The main products, the event was happening on the 15th of September last year. And on the right, you have an example of the results. So in blue, in shades of blue, you see the estimated water depth, which is also, if you combine all the water depth together, is also the flood extent in that specific moment. Again, this is related to one single acquisition. So it's extracted from one single acquisition, satellite imagery. In this case, it was a Sentinel-1. Therefore, it represents the flood extent in that specific moment and not the peak of the flood. I'm specifying it a lot with details because this is why we developed the product 6, which is in this case a temporal analysis of the core flood events. It has the same limitations in terms of area of interest, but in this case we analyze the evolution of the flood. So we will see with these products the persistence of water in the area with a defined frequency, which can be 12 hours daily or every 2 days, etc., etc. In this case, not only we have the evolution, but we also have the maximum flood extent and the maximum flood depth, which corresponds to the peak of the flood. These products, though, can only be generated in recovery phase because we have to generate it after the event is concluded. And in terms of input data, it's more complex because not only we take into account satellite imagery through the generation of the previous product, which is the flood delineation, but also we take into account digital terrain model, discharge information, land use data, precipitation data, river level measurement. So it's much more complex because it is based on flood modeling. So not only we use satellite imagery per se, but also software that are built to represent the equation of the flow of the water. So with this software, we can simulate the behavior of the flood in several timestamps. In this slide, I provide an example of one activation in the past in which this product 6 was generated. In this case, it was the Eta and Iota hurricanes in Honduras. And on the right, you will see the rightmost picture represents the maximum flood extent and depth. And in this case, again, this is the maximum of the entire flood event, not a specific moment in time, but the maximum of the whole event. Now, a bit of details can be also hands-on and that you can exploit also by yourself after this presentation. So this is one of the products that was generated during this summer. It is a flood. It is related to a flood event. Actually, sorry, for February 2021. and related to a flood in Germany. And in this case, this map is one of the map of product 6. So if you put this URL on your browser, you will get these PDF maps, which is one of the product that this service generated for this activation. So I didn't mention, but I will quickly mention now that all the products generated by the Copernicus Emergency Management Service, so all the products that I mentioned here, are provided in full and open access online on the public portal, and so all the products can be downloaded by you and explored for also for further downstream projects, for example. In particular, in this case, as an exercise, I would like to show how this PDF can be exploited for getting to the evolution of the flood. So I hope you can see on the left part of this PDF, you have the possibility to explore the PDF by layer, and on the bottom part in the date and time folder, you have 4 dates. For example, in this case, I'm showing the 27th of January. And so if I activate this layer, I will see the situation of the flood on that specific date and time. And then by clicking, by switching on and off the other layers, I can see the situation of the other timestamps. And this allows the user to have to get to the full detail of the product by understanding the flow of the event. So in each of the slide, I selected a different timestamp. So you can see that I come back to the previous. So on the 27th, it was the beginning. Then on the 5th of February, the flood increased. On the 14th of February, it reduced. And then again, more reduced on the 17th of February. Okay, this was about the flood evolution. A side product, as I said, of the product 6 is the maximum water depth, and this is the PDF product that represents the maximum water depth. In this case, with different shades of blue, you have different depth related to the peak of the flood.
10 minutes, Simone.
See? Thank you. This last slide is just to mention that we have also, for that specific activation, generated a book, a map book with several representation of the same event that you can exploit with this URL. And on that particular product, you will see the characteristics of the flood with the specific detail on some specific areas. And I leave to you the possibility to exploit that product. Now, what I wanted to quickly also show is how you can take advantage of this data, because of course this data can be informative, so you can have a better understanding of the event, but also they can be used for further analysis. And in particular, what I wanted to show quickly is how these products could be used for performing a damage assessment in terms of economical value of the assets that were potentially destroyed by the event itself. So in order to do that, I quickly show one other presentation, which is this one. In this case, this is related not only to flood, is a product that is related not only to flood, but to all potential events. It is a basic European asset map. In this case, this was developed for Sweden, but we can develop, it was developed also for Germany 2 years ago. So a basic European asset map is a map that is a product that has been developed to estimate, evaluate, compare real and potential damages caused by natural disasters across Europe. And in particular, it is important because it can provide damage assessments in areas across different countries. I will go quickly here because my main point is to show this is again was developed within the same framework contract. In particular, in this case, it was the FLEX framework contract because of the particularity of the product. It took, just to give you an example, for one country, it took 4 months to develop this product, because we had to write the technical specification in 1 month. In the second month, we had to go through a tendering process because the Joint Research Center does not produce by itself the product, but it relies on external companies. So the specifications for producing these products has to be written in details, and this is the content of the phase 2. In the phase 3, is the actual production. So it took 50 days for processing the data and to get to the results, and then a few more days for quality review. The input data were geospatial input data, but also statistics in terms of values of economical assets for square meter of the territory. And in terms of results, in this slide, you will see the results. So on the right, basically, we have a geodatabase that can be used to produce a map of polygons. So each of these polygons has a defined economical value, not only in total, but also disaggregated for different socio-economical aspects, such as agriculture and other aspects that I can list in case in the Q&A sessions after. Well, so how can we make use of this information and the information that I showed before about floods to get to further information? And this is the content of an exercise that I propose, and I leave to you I will just introduce it quickly, and I leave to you for the next days maybe, to how to get to a damage assessment related to the flood event that I showed before. So if you take into account the two main inputs, so the product 6 of the flood tempo evolution in Germany, the EMSN 95, and then you take into account the basic European asset map for Germany, you can combine these two in order to get to a damage assessment. So the goal is to calculate the total asset loss due to the flood in EMSN 95. So I didn't specify, but I will do it now, that every activation has a specific code. So in this case, EMSN 95 refers to the flood in Germany that I showed before in the previous presentation. So when you go to the portal, you can quickly go to the code and get to all the results. So the steps required to perform this damage assessment are to load the input data, especially the maximum flood extent of the product 6, and also the basic European asset map. The second step is to clip the BIM dataset according to the maximum flood extent. Then there is a third step to calculate the surface of the polygons. A fourth step is required to calculate the total value in euros for each polygon. And the fifth step is to make a sum of all the values to calculate the total economic loss. Just to mention that this is a very conservative approach, because it considers that all the assets that are flooded, even just a few centimeters flooded, they are completely destroyed. So this is an assumption, and it has to be taken as an exercise for you. Then, of course, in reality, the exercise is more complex because there are also vulnerability functions to be applied in order to define the percentage of loss that you have according to the level of the water. I provided here a few screenshots so you can later use GIS software such as QGIS or ArcMap if you have, but QGIS is preferred as it is open source, so you don't need a license, for example, to use it. And these slides will go step by step in how to extract the product. So for step one, how to load the two products, you see here with the orange circle, which is the layer that you need for both the beam product and the flood product. Once you load in QGIS the two layers that I mentioned, you see on the bottom now in this slide the beam and the flood extent in blue, the maximum flood extent in blue. You can perform various processing, and in particular in this case into vector geoprocessing tool, you can get to the clip tool that will be used to clip the beam over the maximum flood extent. This is the screen of the tool and the input data that you have to input to perform the right calculation. This is a few details on how to perform the processing in case you have invalid geometries, so to overcome the issues of possible invalid geometries. Then what you will get is the clipped beam, and for each of the polygon you will have on the right all these values, and what is important for this exercise is the total SQM, which is the total value for square kilometers. For example, in this case, you have for the polygon in red, you have 1.53 euro per square meter of value. Next slide is just for showing that you have a portion of the territory with a wide variety of value from and also with different predominant use. The next step, the third step, would be to calculate the area. I will go quickly because I'm seeing that I'm about to the end of my time. So calculate the area of each polygon. The next step again is to calculate the value for each of the polygons, so a multiplication between the total value per square kilometer and the surface, and then you have in this case for each polygon the value on the right in the orange circle. As a last step, okay, this is just a way to represent the economical value with a specific symbol in order to show in brighter red the highest values. And last step, in order to get to the total sum of potential loss, you can perform a basic statistic operation on the field value, and you can get to the sum. In this case, the sum is more than 1.5 billion of euros. So this is the end of my intervention. Again, I will be available in the Q&A session to answer to any potential questions.
Thank you, Simone, for your interesting speech. Thank you. Now it's Daniele's turn. So thank you, Daniele, for being with us today. Of course, I see that your webcam is already on. Please turn your microphone on. You should have Yes,
Can you hear
you
me?
should be able, yes, to share your screen.
Yes.
Okay, the stage is yours, Daniele. Thank you.
Okay, thank you. Okay, good morning, everyone. I'm Daniele Oxoli. I'm working in Politecnico di Milano in the Geolab teams with Professor Gianninetto and Brovelli. And my work is mainly, say, 100% of the project I'm working on is on GIS, and most of them also connected to Earth observation. In the recent past, also, we move on this topic, which is the air quality, also based on Earth observation, which is quite an emerging topic for many aspects and for sure interesting for the next future, that Professor Gianninetto was explaining to you about the European vision of the Earth observation in the next 30 years. So let's start with a brief introduction on what is air quality. And it's a complex question on what is air quality, but let's try to answer with some simple statement that can help to understand the complexity of the problem and to divide it into pieces and better tackle it. So the air quality generally means that the state of the air around us, and this quality is kind of essential to maintain some balance between our planet, not just for us, for humans, but for many other ecosystem and animals and vegetation and so on. So the poor air quality affects a number of ecosystem in our work and a number of economical value in our work and so on, and can be also affected by a number of a great variety of sources that can emit some pollutants or some disturbances in the atmosphere, creating bad air quality. The scenario of emission is really complex, and you can try to appreciate it through this simple picture, but we can try to define two main source of emission, which are the natural emissions. That includes, you can think about volcanoes or some polluted that is volatile from the soil into the atmosphere, and many others. What is interesting, especially also for us and for my research, and also for the let's say for the scientific point in this period, is about anthropogenic emissions, so the emission that humans introduce with their activity into the atmosphere. And emissions are created by most of the economical activities of in our planet, that ranges from the foundry, transportation, agriculture, power production, and many other processes. And those processes will try to accumulate or interact in the atmosphere and getting worse, or let's say they can sum up in creating bad effects for our air quality. I will just mention here, without entering too much into details, which are the most abundant species of pollutants that are currently a concern, and they are currently monitored for ensuring air quality, that are the carbon monoxide, the sulfur oxides, and all the list you see here. It's not important for today to know most of them, but of course, for different applications, they can have different relevance, and so I suggest you to learn about the chemistry of these compounds that are of interest. The first, let's say, concern for, let's say, the one that is closest to us is our health. And those are two statements that were registered in the previous discussion about air pollution, one about the European environmental agencies, and the second one from the World Health Organization, that state that currently the air pollution is the most important environmental risk related to health, to human health, and is perceived from us as citizens as the second biggest concern after the climate change, even if we will see later those two things are also connected. But from other records, we can state that the air pollution is the fourth greatest overall risk for humans, for the health, human health, after other problems about pressure, dietary risk, and so on. So he say it's the cause of premature deaths of more than 6.5 million of people per year. And so you can understand the scale of this problem and why it is important to explore it with all the tools and all the knowledge that we can have. About the climate, the simplest way to describe the interaction with air quality and climate is that many of the air pollutants that we emitted or they are naturally emitted are also greenhouse gases. And as you may know, the greenhouse gases are the fundamental cause of the greenhouse effect, and therefore they help, they trigger the temperature of our planet to be warmer. According to what we have seen in the last slide, you can try to figure out how this is really a global problem, not just connected to the local air quality on your city, but it's a magnification of effects that affect many aspects of our life, and especially they affect the trajectory of our planet towards sustainability. So these words that today is really notorious from the news and what you have listened to or read on newspaper, it's a real concrete problem. So the air pollution is connected indeed to many sustainable development goals that ranges from the climate mitigation to energy to health and so on. So you have now a picture, a very high level picture, how air quality is considered by our politics, by our citizens, by your own its effect on the quality of your life and the quality of the life on our planet. So let's move now to something that is more connected to our point of view as scientists. So how we can monitor the air quality and to pass this information to the other sector that needs heat as a vital source of knowledge for managing their activities. So the air quality monitoring is nowadays is mainly computed using ground sensor. So there are directives, there are laws that impose the states to have a certain number of measurements of air quality and use them to compute some indicators that allow to understand the current and the past and also the future of the air quality within given geographical region. And so those data are the data from ground sensor are nowadays, again, currently, let's say, they are the main source of information for our authorities. And why? Well, our ground sensors, you can understand, are like fixed station, or even mobile sensor that sample the air that is around them. So basically, they get in contact with the air and their pollution, and so they can provide kind of direct measure. And generally, those information are expressed as a time series of records related to a specific point on Earth. So this is the model of the data that is available. And those data are generally produced by local ground sensor network that then are merged together to scale up to national and international air quality monitoring. But why we are here today is because there are some limitations we will see later, also on the use on ground sensor. And so the interest now is towards the air quality monitoring from space. The information from space, as you may know now, that can provide kind of consistent and also daily high resolution estimates of atmospheric trace gases that are the pollutants that we listed in the previous slide. And those components that are let's say, captured by the sensor of the satellite sensor for all our world are affecting also somehow the air quality, so they are connected to that. And those kind of data with respect to the ground sensor are, let's say, generally quite new from the technological point of view. And so there are not tools, so easy tools to handle that, but we will see some high-level application where you can at least visualize and explore what the satellites see. And the push to this air quality monitoring from space, say a big contribution, is for sure given by the Sentinel-5P satellite, which is one of the satellites of the Copernicus program constellation, and is actually the most recent and advanced observation platform that provides open measure of these atmospheric constituent on a global scale with a daily resolution. In the official portal are linked here for downloading those data. As I told you, the format of this data is quite tough to handle with simple GIS procedure, but at least we can try to explore them and see what we can do for an easy integration to the tools that you already know. We will see something later. And what is the difference? So in these slides, I bold estimates of atmospheric trace gases, and in the slides of the ground sensor, I bold the word direct measure. The point is that the satellite, as all the remote sensing platform, doesn't touch the object, or doesn't get in touch to the object of which is measuring the properties. So the satellites, the satellite sensor for air quality are basically multispectral cameras. So the same cameras that you learned during our previous courses of GIS for school, but it works almost in the same way. So we measure a kind of ratio between radiation in different spectra, and can understand in this case, in this specific case, how much of this radiation is absorbed by the atmosphere that is in between the satellite and the ground. And using this information, we elaborated with some sophisticated algorithms. He's able to understand the concentration, kind of an estimate of the concentration of these pollutants or trace gases in the column of the atmosphere that is below the sensor. And the good things with respect to the satellites, that this data, this information that is encoded on maps that have a global coverage. So now we will see some really basic application, but really interesting of those both ground sensor and satellite based information related to air quality. And we will see them first starting with this project that is, I select this to show you because, as I mentioned before, all those ground sensor networks are kind of locally based, and also the data distribution happens locally, while there are some global project like this World Air Quality Project that aims exactly to create or to put together all this information to have a global coverage, also from observation from the ground sensor. An interesting indicator, as you know, that there are many pollutants that are monitored, but there is an interesting indicator that is called Air Quality Index, or AQI, which is exactly created or computed based on the concentration of many pollutants that are in the area specific location. And this is used as a global indicator, a general indicator to understand the quality of the air with respect to human health. So it's really important and a summarized indicator that can be used, that is usable to compare the situation across different locations in the world. And this project, it's started in 2007 and is still ongoing and provides some ready-to-use tools to visualize and explore those information about air qualities. I create these little slides for you. It is a simple practice slide where you can that you can reuse to add some of the map tile are called of this project that are provided from the Water Quality Project into QGIS. And you can have, of course, more info from the link, but we can also see how this works. And if we open our QGIS, what we need to do is first go on having a look on this website link that is included in the slides. And there is this API, which is a kind of interface, a kind of program interface or kind of protocol to exchange those information, those maps through the web, and they can be also used within QGIS, for example, or other web mapping platform. And we need to just to have a look on this URL and do these parameters. And the idea is that I enter in QGIS and try to add a XYZ layer, creating a new connection. I give a name. I copy this URL from the website here, and I need just to change this part of URL according to the map that I want to visualize on my map. We will use this AQI parameter, which is the one is for sure working. And then we simply connect to this service, which does nothing that provides some points with some marker that is updated in real time, displaying the value of the air quality index. So I just zoom in on Romania, which was the scholar of this Bucharest, I believe, asked for the express interest in air quality. So you see that at least at European level, we have good coverage of this indicator, and so you can have in real time directly on your QGIS this information to be added to your analysis, or just to create something that is informative, or just for curiosity, for example. As you see, some of the sensor do not work always, so there is still some lack, and these maps are updated within 15 minutes and 1 hour. So some sensor may pop up or just turn off. But this is a real nice example on how we can have a overlook on the air quality, global air quality, using ground observation. But let's move further on the space. The application of the Sentinel-5P especially was became kind of notorious during the pandemic of COVID-19 because it was the imagery of the satellite was used to show to the public the effect of lockdowns, especially over different regions in the world. And to say the most important, also the most useful species of pollutants is the for doing so is the nitrogen dioxide, so what you call NO2, that is produced or emitted in the lower atmosphere, especially by combustion process. So combustion process involve many human activities. So it's a good indicator to assess at least the activity intensity, the human activity intensity on places. And many of these time lapses were created to show the decrease of these pollutants in the region that were affected by lockdown. To create such a kind of visualization with using the Sentinel-5P data, we can, of course, take the raw data, try to process, but as I told you, there are nowadays not so user-friendly tools to do that. The one that I would like to suggest you to have a look is the Google Earth Engine, which is a really powerful platform for Earth observation that includes a catalog also of the Sentinel-5P data, and it's able to combine with some line of code. So this is a bit advanced, but this is just for information. We few line of codes to produce those views of those data analysis that include multi-temporal observational quality data from the Sentinel-5P. The good things is there are many applications that relies on these technology that are more user-friendly, like this one that I suggest here in the slide, where with who you can play with, and just changing periods or type of pollutants, you can produce your own visualization for the different situation. Like this case was the lockdown situation in 2020, before and after for the Lombardy region, so the region of where Milan is, and we can also have a look here. It's a really simple tool, so you just need to change the dates using the calendar and update the maps, zooming on the region of your interest, and you can have a view of your pollutant average during the time you specify in the periods here. And this is again between the March of 2019 and the March of 2020, where the region of Milan was in a strict lockdown situation, and you can appreciate the decrease of these NO2 trace gas in the troposphere.
10 minutes.
Yes?
10 minutes.
Yes. So far we also we just have a look on the human influence on air quality, looking at our data. But another interesting application, or something that is currently used to tackle air pollution, that is not always a problem, for example, for health, but it can be a problem also from some activities, like the volcanic eruption that generally are a danger for, I don't know, for example, for air traffic. And we know that volcanoes contains gases. When the magma of volcano contains gases, and when they erupt, these gases are released in the atmosphere. And among those gases, there is the sulfur dioxide, that is the SO2, and that is a concern because it has an influence of climate and also on health, and is released in big quantities in the atmosphere during these big eruption of volcanoes. This is the recent case of the La Palma volcano erupting in 19th of September of this year. And this is the multispectral optical view of the volcano eruption, but we can also monitor this phenomena by looking at its emission of SO2, for example. And how we can do that? We can, for example, use the EO browser, that is a tool that you should have seen at least, to create, for example, a temporal view of the phenomena. And you can see here in the GIF, the animated GIF on the screen, that during the first days of September of this year, where the volcano was not active, the situation of SO2 in the atmosphere the SO2 was almost absent in the atmosphere at that time. But just after the eruption, it's quite clear visible the plume of the volcano that affect all the surrounding region with the emission of these gases. And you can monitor, say, indirectly the activity of this volcano to have to combine also the another kind of Earth observation data to the typical study of these phenomena, these natural phenomena that affect, of course, the air quality. And it's quite simple to reach these result. We can go just simply on the Sentinel Hub, looking for Sentinel-5P data and looking for sulfur dioxide. And once they are searched, you can visualize first some of them, or you can compute here using a specific the specific command of the EO browser. You can compute a time lapse, for example, for the weak concentration of these pollutants around this area that's quite big, and save it as an animation, as I did for this slide. Or you can even take simple picture of the phenomenon time step by time step within the EO browser. Okay. So those were just some insightful example of the powerful of those satellites. But the question is now that may rise on you, it's do we need both the satellite and the ground sensor? And I would say yes, that we do. And I try to summarize the why inside these slides. And we know that the ground sensor has there are really time results, so they can sample every few minutes and provide that information of air pollution a few minutes. And they provide also, we can say, accurate information because they are in contact with the pollutants. And those information are necessary nowadays for computer quality indicators that are requested by the law. On the other hand, the satellite sensor has a lower, let's say, temporal resolution. Today, it's up to 1 day imagery. And it provides the estimates of these of the air quality, not direct observation. So we need modeling for bringing those observations down to Earth. And here is the nexus between the ground sensor and the satellite sensor, because they can cover the lack they have in their practical usage, and if we are able to merge them in a clever way, we can have also, let's say, some benefits, and those benefits are connected, especially to the spatial coverage, because the ground sensor are point-wise information that doesn't cover the Earth with the same density, while the satellites looks all the portion of our land and water and can have this full spatial resolution. And another point is about data harmonization. I told you before that the ground sensors are managed quite locally, while for the sensor we have an homogeneous view of the data that is also managed by an international effort. So we have one sensor where all the people work on it and look at the data and use those data, instead of having a lot of sensors and a lot of people that manage and then try to merge. So those are the trade-off between the two technologies that currently are both of interest and both useful for our studies and for our policies and so on. And another, let's say, I will conclude this presentation that just explain what will be the next. We point out that one of the problem with the satellite is the temporal resolution, for example, because it's the times lower than the one of a ground sensor. And let's say in the past with satellite, we could only check some large scale episodes of pollutants that one scattered in time. Nowadays, we can have this daily view of the area above us, using the satellite, the satellites that are listed down in this picture, while in the next few years, the direction is connected to geostationary mission. Those geostationary mission are those satellites that looks at the same portion of Earth for all the time they fly, and they can provide information, so observation hourly. So one observation per each hour. So decreasing the gap between the satellite sensor and the ground sensor, at least on the temporal resolution. So in the next few years, this will be the frontier technology that will be explored to continue this improvement in the knowledge of our air quality. So thank you. I hope this was useful for you, or at least insightful.
Thank you, Daniele, for your very interesting speech. And you touched different topics related to air pollution, and you also showed different tools, web tools. So thank you very much. Just a note for teachers and students, and don't worry if you missed anything from representations, for example, like the internet links or where the data can be found, because in the coming days, we will bring you the material shown today, so don't worry. Now we have a 15-minute break, so we can catch out breath and stretch our leg for a while, and we start again at 11:10. We have a very small delay, 10 minutes, because we started a little bit late this morning. We had some technical issues with Microsoft Teams, so 15-minute breaks, and then we are back again. Thank you.
Mark, I'm sorry. Can I just take 1 minute before leaving for the coffee break?
Yes,
Just to think. Okay, thank you. Just two things. I just remind you that we have sent to pupils the link for the survey, so you will have received the notification on Telegram. So if you want during the coffee break, you can take 2 minutes and fill in the survey. And the last thing, if you are already here, if I would like to invite you all to switch on the camera just for 5 seconds, so we can take a picture and then we can enjoy our coffee. Well, okay, I've taken a picture, but maybe we can repeat this then after the break.
Okay. Thank you, Elisa. So see you back in 15 minutes with the next speaker, Julia Dame, my friend Julia. So see you back. Francesca, se mi senti, riesci ad accendere il microfono?
Eccomi.
Adesso
Sì.
ti sento. Ok, prima c'era stato qualche problema con te.
Sì, perché dovevo riscaricare l'applicazione, non mi riconosceva né microfono né cuffie, niente.
Ottimo, ci sei.
Sì, ci sono.
Grazie. A dopo, grazie.
A dopo.
Okay, we're ready to come back. I know it is always difficult to come back after a break, after a coffee break. Always difficult. I hope that everybody has reconnected. Now, the next speaker is Yulia Dana. Yulia, thank you for being here with us today. I see that you have already turned on your camera and your microphone, so the stage is yours, Yulia.
Thank you very much, Marco, for your invitation to be part of this GIS project that promotes the use and exploitation of EO data and GIS tools in schools. I will now turn off my camera and share my presentation on the marine ecosystem. Can you see my presentation?
Yes, Yulia.
Okay, so I will start it. So, as you already know, Earth is the only world we know that has large areas of surface water and a lot of oxygen in its atmosphere. About 71% of the Earth's surface is water covered, and the oceans hold about 96.5% of all Earth's water. When the water is heated by the sun, it changes to a gas known as water vapor. If this gas is cooled, it turns back to water droplets, forming clouds and rain. So water is never sitting still. If this water cycle is made possible because Earth is in the Goldilocks zone of the solar systems. As the third planet from the sun, Earth is neither too hot nor too cold for oceans to exist. The temperature is also just right for life. As mentioned before, water exists in the air as water vapor and also in rivers and lakes, in ice caps and glaciers, in the ground as soil moistures, and in aquifers. This spectacular globe illustration created by the United States Geological Survey, abbreviated USGS, shows blue spheres representing relative amounts of Earth's water in comparison to the size of the Earth. The largest sphere, representing all water on, in, and above the Earth, is about 1,385 kilometers in diameter. The smaller sphere represents Earth's liquid fresh water that is present in groundwater, swamp water, rivers, and lakes. All of this water is fresh water, which we all need every day, but much of it is deep in the ground, unavailable to humans. The smallest sphere represents fresh water in all the lakes and rivers on the planet. Its diameter it's about 56 kilometers. So the water amount on Earth is limited. Sustaining life, this precious resource has been circulating between Earth's surface and atmosphere for over 4 billion years and changing between a liquid, a solid, and a gas along the way. Although the total amount of water within the cycle remains constant, the way it is split between its various reservoirs changes continually. With the current climate crisis leading to more extreme droughts and floods, the availability of enough fresh water where we need it is a growing concern. Presently, a lot of advances have been made, especially in space-based observations of the water cycle. The Copernicus program is proving vital for long-term, consistent satellite observations. As my colleagues mentioned, the previous speakers mentioned before, the Copernicus program is composed of 3 components. the satellite data, the in-situ data, and the components related to the services. It is important to know that these Copernicus services dedicated to the study of the atmosphere, marine environment, land, climate change, security, and emergency are offering free and open access to satellite and in-situ data, and they are bringing value-added information. The satellite missions that support the marine monitoring are Sentinel-1, Sentinel-2, Sentinel-3, and Sentinel-6. In Sentinel-1 is a 2 satellite constellation that provides an all-weather day and night radar imaging capability for Copernicus Marine Services. The Copernicus Sentinel missions in general support marine monitoring by providing timely, continuous, and independent data on the behavior, use, and health of the oceans and the associated coastal zones. In this animation, you can see the iceberg entitled A74, which was approximately 1.5 times the size of Greater Paris, that detached from Antarctica's Brunt ice shelf. For almost 6 months, it has remained close to the shelf it broke away from, owing largely to ocean currents. In August last year, strong winds have spun the iceberg around the western tip of Brunt, brushing slightly against the ice shelf before continuing southwards. If the drifting iceberg would have hit the unstable ice shelf with severe force, it may have triggered the release of a new massive iceberg. In this second Sentinel-1 mission, we can see the oil spill from the Grande America vessel. The Italian container ship was carrying around 2,200 tons of heavy fuel. It caught fire and sank in the Atlantic about 300 kilometers off the French coast in 2019. The oil slick is a large, dark patch in the center of the image, stretching about 50 kilometers. Satellite radar is particularly useful for monitoring the progression of oil spills because the presence of oil on the sea surface slows down the wave motion. Since radar basically measures surface texture, oil slicks show up well as black areas on a gray background. Next, we have a couple of Sentinel-2 images. Sentinel-2 is a 2 satellite constellation representing a polar orbiting multispectral high-resolution imaging mission for land and coastal areas monitoring. In this first image, we see the algae blooms swirling around the Pacific Ocean, just off the coast of Japan. In this picture here, we can observe high concentrations of algae around the Hokkaido Island, the second largest island of Japan. This particular algal bloom measured more than 500 kilometers across and 200 kilometers wide. Algae blooms refer to the rapid multiplying of phytoplankton. That means microscopic marine plants that drift on or near the surface of the sea. Excessive algal growth can become visible to the naked eye and collectively tint ocean waters, allowing the detection of these tiny organisms from space. Although algal blooms are a natural and essential part of life in the sea, human activity is also said to increase the number of annual blooms. Harmful algal blooms can be stimulated by environmental factors such as light, warmer water temperatures, and excessive nutrients. Apart from the role played in the food chain, phytoplankton has an impact on the global carbon cycle by absorbing carbon dioxide on a scale equivalent to that of terrestrial plants. Therefore, phytoplankton has a role in climate change. In this second image, we have the Danube Delta, which is the second largest river delta in Europe and an UNESCO World Heritage Site. In this true color image captured last year, we see the vast reed beds pictured in brown, which is typical during this time of the year. The Danube is visible on the left part of the image before splitting into the various channels and branches that flow into the Black Sea. The distinct light green colors in the sea are likely to the sediment carried by the river, while the emerald green present in the lagoons of Razim and Sinoe are due to a high concentration of algae. The next image is acquired by Sentinel-3, which is a 2 satellite constellations that provides a multi-instrument capability to measure the ocean color, the sea surface height, and the sea surface temperature. This image depicts the thermal signatures over southern Italy, the Mediterranean Sea, and Sicily, with the hotspot of Mount Etna clearly visible. This image is important to take note. It shows the brightness temperature, which corresponds to radiation emitted from the surface. Further processing is needed to turn this into an actual temperature map. The land surface is shown in red-orange colors, corresponding to a brightness temperature of 296 to 320 Kelvin degrees, and the blue colors are over the ocean and correspond to a different temperature scale. The dark blue to black areas correspond to clouds, which are opaque to thermal infrared radiation. The second Sentinel-3 image is featuring Spain, Portugal, and North Africa. The image clearly shows the Strait of Gibraltar between the Atlantic and the Mediterranean Sea. Swirls of sediment and algae in the seawater can be seen along the southwest coast of Spain and along the coast of Morocco. We can also see the desert, the dry desert of Morocco, and the snow-covered peaks of the Atlas Mountains. Next, we turn our attention to the Marine Copernicus Marine Service. It represents the marine component of the Copernicus program. It provides, as mentioned before, free of charge, state-of-the-art, regular and systematic data and information on the state of the blue, white, and green ocean on a global and regional scale. A brief presentation of the Copernicus Marine Service is available at this link. You will have the presentation later this week. So, regarding the products provided by this service, we have the ocean monitoring indicators. As the global ocean is responsible for regulating the Earth's climate and sustaining life, these ocean monitoring indicators are of high importance. The ocean is currently undergoing swift, stark, and severe changes from natural variations, overexploitation, and other anthropogenic influences. Human-induced climate change has already contributed roughly 1.1 Celsius degrees to global warming, causing critical changes which are affecting the ocean. So the ocean monitoring indicators are essential ocean variables used to track the vital health signs of the ocean and changes in line with the climate change. Among these parameters, there are, for example, temperature and salinity, currents, sea ice, sea level, and sea state. And these indicators are showing the current status. They can show time series and trends, anomalies, extreme variabilities at global level or for specific regions such as the Antarctic Ocean, the Baltic Sea, the Mediterranean Sea, and so on. Now, let's access the Copernicus Marine Service and explore some of the ocean products. So we go to marine.copernicus.eu and we access the section related to ocean products. We can choose, for example, for the regional domain, the global ocean, a specific time interval if we want, and the parameter we look for. So in this example, we will choose the sea surface height, and we will find 10 products, 10 ocean products that correspond to our criteria. And for example, we will choose this one. We can press the view product button, and a map showing the sea surface height above the geoid is shown. We have the legend of this map expressed in meters. So we have higher sea surface heights values in the Pacific Ocean, and lower sea surface heights in the Arctic region. We can also exploit this data. We can go to tools. We can download, firstly, we can download this data as netcdf4 file, a specific file for this type of indicator, or as PNG files. And we can also go to tools and to advanced view, sorry, and create plots showing the sea surface height along certain profiles, along certain distances. For example, we have here the sea surface, the difference in heights from the Atlantic Ocean to the Arctic Ocean. We can go back to the marine service, to the ocean products, and choose another product. For example, we can go to the Mediterranean Sea and choose another parameter, for example, temperature. And we have also a number of products. We can choose this one. We click on the view product, and the temperature will appear on the screen. So we have this product corresponding to yesterday. We can see higher temperatures near Turkey and Greece, and lower temperatures near Italy and Spain. We can create a time series
sorry, but we are not. We can't see your screen. We see always the slides. So
the slides,
we have to share not one specific window.
Yes, I will try. So I will stop sharing and share again. And this is what I wanted to show.
Yes, now it appears.
So can you see?
Now it is okay. Thank you.
Is it okay? Okay. Yes. Thank you for letting me know. So if we select a certain point on the map, on the temperature map, we can see the profile of temperature in that point. I think it's just a moment. So we have the temperature map. We go to advanced tools. We can open the product in Google Earth, for example, and later I will come back to the profiles. A KMZ file is downloaded. And shown in Google Earth. Can you see the Google Earth application?
Yes, I believe that this is what we see.
Okay, so we come back to the product. We go to tools. We want to create a time series in a specific point. We click in a certain point, and we can see the plot of temperatures over a year in that point. So we have the evolution of the temperature in a time interval of 1 year. We can also create animations. This tool is very interesting. We can enter the start date, for example, 4 days ago, the end date yesterday, and we generate the animation. When the animation is ready, we can download the video as an MP4 file. So we can create animations for our interest areas. This Copernicus Marine Service has a very beautiful ocean visualization tool, which is suitable for for users with different levels. For example, we have the beginner version, the intermediate version, and the expert one. We will access the Explore My Ocean Learn version. And we can see different parameters, the ocean monitoring indicators listed in the left part of the application. For example, we can choose sea surface salinity. We have the results from 2020 to the present date. The salinity of the oceans represents the amount of dissolved salts. The average salinity of the ocean is 35 grams per liter of water, and in the oceans, the salinity varies between 30 grams per liter in the North Atlantic to 40 grams per liter in the Red Sea. We can switch, for example, to temperature and see the temperature file on the global scale. Also, temperature is important, is a real key variable because it's essential for a large number of applications, such as forecast computations, the monitoring of meteorological phenomena such as cyclones and typhoons, the management of the marine resources and ecosystems, for climate studies, and so on. We can also view the currents, which are also important. This product shows the current velocity at 30 meters below the surface. Currents warm cold areas and carries the heat away from the hot areas, thereby distributing the energy provided by the sun. This makes them also key players in the Earth's climate. They are generated by a number of forces acting upon the water, including wind, the Coriolis effect, breaking waves, cabling, and temperature and salinity differences. If we go back to the visualization tool, we can access the intermediate planisphere. We click on the Explore My Ocean light version. We also have the same parameters. For example, we can choose the chlorophyll, and we see an estimate of the chlorophyll for tomorrow. But we can also see the chlorophyll in different moments in time. For example, in July this year, in April, and so on. At the base of the ocean food web are single-celled algae and other plant-like organisms known as phytoplankton. The phytoplankton growth depends on available sunlight, temperature, and nutrient levels. Because cold waters tend to have more nutrients than warm waters, phytoplankton tend to be more plentiful where the waters are cold. If we choose the pH is has a scale between 0 and 14, with 7 being a neutral pH. Anything higher than 7 is basic or alkaline, and anything lower than 7 is acidic. A higher acidity equals a lower pH. Since the Industrial Revolution began, the concentration of carbon dioxide in the atmosphere has increased due to human actions. During this time, the pH of surface ocean waters has fallen by 0.1 pH units. Ocean acidification is currently affecting the entire ocean, including coastal estuaries and waterways. It is also one aspect of global change. We can perform, using the tools from this application, we can perform a detailed analysis of the pH in certain points or along certain lines. So we go to full viewer and we use, for example, points, and the plot of the pH is instantly showed. Starting with 2019, it is very interesting to notice that we can see these parameters and the other parameters which are here at different depths. So we have, this is acidification, the pH at the sea surface level, but we can change the depth. And we noticed that the pH is becoming higher. That means the acidification is lower in the depths of the ocean. We go even deeper and we see lower values as we dive deeper into the oceans and the seas. Another parameter. Yes.
5 minutes.
5 minutes. Okay.
Yes.
Okay. So we also have just a moment. We also have the European Atlas of the Seas, which is very important. We have a lot of products for the marine environment. We have the seabed habitats, and here we have, for example, the map of Posidonia oceanica, which is a seagrass present in the Mediterranean Sea. In our exercise today, we will try to map Posidonia oceanica in this area, and for this we will use a Sentinel-2 image downloaded from the Copernicus Open Access Hub. The image was acquired 4 days ago. Considering the fact that Posidonia oceanica is flowering in September-October. If we go back to the presentation, can you see my presentation now?
No, we can't. We still see your browser.
So it is important to learn that water has a higher reflectance in the visible spectrum and high absorbance in the near and mid-infrared spectrum. So we cannot use these bands acquired in the infrared spectrum for monitoring the water. At the same time, the chlorophyll, the water that has a chlorophyll content, a high chlorophyll content, has this spectral signature where we have a higher reflectance in the green visible light. As the chlorophyll is getting lower, so does the value of the reflectance in the green interval. So we, having this in mind, we connect, we are adding the necessary bands in our QGIS exercise. So we are adding the visible bands in blue, green, and red. And also the band B5, which is acquired in the red edge band, in the red edge portion of the spectrum. This is important to add this band because red edge is sensitive to the vegetation, to the chlorophyll content. Now, can you see my QGIS application?
No.
No.
Still see your PowerPoint presentation.
I'm very sorry for this. Now, can you see QGIS?
Yes.
Yes, so we have 4 spectral bands, 3 of them in the visible spectrum and 1 of them in the red edge. And we perform simple raster calculators using these bands. First, we will compute Vari, which is a spectral index based on the green band, which is B3, minus the red band B4, divided by their sum, minus B2, which is the blue one. It is important to mention that the Sentinel-2 has to be atmospherically corrected. So the image has must have atmospheric corrections. Next, we will perform another raster calculation. We will do a ratio of the difference and sum between B3, the green band, and the blue one, divided by their sum. And this is ratio based on green and blue. And the last calculation, we will use the same approach, but using the red edge band B5 minus the green one. As you learned, the green one is essential for these calculations. So their difference divided by their sum. So B5 plus B3. So here we have the ratio using red edge and the green visible green. After we generate,
sorry, we missed.
After
you said.
After we generate, can you hear me? After we generate these bands, we go to raster and we merge them. So we in the input we select the generated index, and we place each input file into a separate band. And this is the result. We can change by its appearance by using a different band order. For example, 2, 3, 1. And the result is this one. We have a better insight on the aspect of the coastal areas, of the coastal waters. However, an accurate mapping of Posidonia oceanica needs complex models, but based on this approach, we can have some preliminary results when looking at crystal clear and shallow water. This means the results can be worked in different locations or using satellite images collected under different environmental conditions. This is all. Thank you very much for your attention, and I'm very sorry that I couldn't share the content at any time.
Thank you, Julia. Thank you for your speech. Interesting and also is at the same time. And this last analysis is a gift to our friends from Formentera who are very interested in study Posidonia oceanica. As you said, the correct and accurate mapping of this Posidonia would require complex models. It is possible, but not very simple to map Posidonia oceanica. However, the approach that you have shown is very simple and could give some very preliminary and not accurate results, but it is very simple and can be replicated. And again, I say don't worry, but we will supply you with all the information materials in the next days. Now, we move to the last lecture. Francesca, could you please? Hi. Okay, I see that you have already turned on your camera. And Francesca, thank you again for being with us today with a very short notice. Thank you very much, very appreciated. And the stage is yours, Francesca.
Okay. I need to share my screen, so I ask to the Julia.
Yes, Julia. Could you please unshare your screen, please? Thank you.
Okay. I have a lot of things open. Okay. Thank you for inviting me to have this in this webinar. I'm really glad about that because I can share the things that I use every day in my work with students around Europe. So thank you. I am Francesca Giannetti and I am a research fellow at the University of Florence in the Department of Agriculture and Forestry. And my main expertise is to use remote sensing and GIS to manage and to monitor the state of forests, especially in Mediterranean countries, but also at European and at European level. So my expertise is to use especially optical data. These are come not just from satellite data, but also from airplane and drones. So I use also drone to have a very high precise monitoring of some forest, where we have the same data that we can have by satellite in 1 centimeter resolution, so really high resolution that give us the possibility to understand every leaf of every trees what's happened. During my lesson and this presentation, I will show with you some practical tools that you can use by yourself to monitor the state of forest. Some of these tools are developed at European level, some at world level, so you can use this data in all parts of the world where do you want. Forests are one of the main important ecosystems to fight climate change, since they are the first ecosystem to stock carbon dioxide, and they cover 1/3 of the land of the earth. And there is some countries that have more or less the 50% of the forest cover all around Europe. These countries are Russia Federation, Brazil, Canada, United States, and China. The rest of the world is covered by the other 46% of forest land. Forest provides a very large, important ecosystem service. They provide us oxygen, so we need to preserve them to breathe. Without forest, we cannot breathe. And we need to monitor and to measure them every day in order to understand the state of forest, to understand the health of forest ecosystems, and because they are really important for our life on the earth. In Europe, we have 227 million of hectares of forest, and they cover the 35% of the total land. And if we add also the other woodland that are shrubs, lands, we have additional 27 million hectares. Of this hectare, the 46% are coniferous and the other are broadleaf, so they are a species that have a leaf-off period where we don't have a chlorophyll content on the plant, especially in autumn and winter. And then in spring and summer we have leaf-on, so they provide us some benefits. Here you will find after in the presentation some videos that I just link here to have more information about forest. One video is from FAO and one video is for Forest Europe. But forests provide us not just oxygen or carbon stock, but they provide a lot of environmental function. They are the first ecosystem to fight climate change. In fact, in Europe now we are thinking about to plant 1 million, 3 million, 7 million of plants around our cities, because the forest just not provide us a carbon stock, but also air pollution removal. So they are able to capture, for example, PM10, that is a high pollution in their leaves, and so put them in the wood. So if they are able to capture, this is not in the atmosphere. But they provide also an important aspect related to soil erosion. So when there is, we saw before some flood extreme events, they provide us the function to protect soil, so to don't have the loss of soil, because in the soil, in the forest, there is also other carbon stock there. So not only in the trees, but also in the soil, in the forest, we have a lot of carbon stock there. And they are also important for the hydrological regulation, but also to provide unique habitat for some other animal and tree species. So we need to preserve the biodiversity of the forest. They are also an economic value, because wood, for example, is one of the sustainable materials that we can use to build our building, to build our desk, to build chair. And if we use wood, this is a natural material that we can use without using plastic or other things that go in the brush without any possibility to destroy it using the things. One of my professors say the age of wood is never ended from the past, from the first people that arrived in the earth until now, because this is a very important material also if we want to reduce the use of other types of materials. But also they provide social benefit, because people go in the forest to have trekking and social life and cultural value, because, for example, in Europe, we use forests for our life every day. From the past, for example, chestnut was one of the trees that ancient Romans put everywhere in Europe, especially, for example, in France, or we use other types of species, for example, from the past that now are all around Europe. However, in the last year, especially because for climate change and and the changes of temperature and extreme event, we also in Europe we register an increasing of natural disturbances. What are natural disturbances? Natural disturbances are events that destroy forest, and in the last year they are increasing. These events are mainly there are forest fire, especially in Mediterranean area, but we saw in the last year that also, for example, in Russia or in tropical forest, the forest fire increase. So we have this huge amount of dioxin released in the atmosphere because forests burned. Then drought events that are especially in Italy, Spain, Greece, and all the Mediterranean countries of Europe is increasing. So drought events is where water scarcity reduce the health of forests, especially in Quercus forests that are mainly distributed in the Mediterranean country, and also the decreasing of health in forest ecosystem is one of the main point for insect outbreak. So insect can destroy a large hectare of forest. Now, for example, in Italy, we have this problem in the north where there was a huge windstorm that was called Vaia. And now also the forests that were close to the forest destroyed by windstorm are attacked now from an insect that is the bostricle, is an insect that eats the leaves and all the leaves are dead and the trees are dead. How we can monitor this natural disturbance? You have already know the vegetation index, but here just a simple images that give you the main band that we use usually to monitor the health of forest ecosystem. One trees that is health, so with chlorophyll content that is good without any problem, usually reflect a lot in the near infrared band, and we are able with the vegetation index to understand the health of vegetation. One trees that is stressed, for example, in the near band, the reflectance is lower, so we can monitor this event just going to understand what is the better vegetation index to monitor the health of forest. One of the most used vegetation index to monitor not just forest fire, but in general natural disturbance is the normalized Burner ratio index that is calculated using normalized difference between the near band and the SWIR band. And here you can see that burned area or stressed area in general have a high reflectance comparing to stable, healthy vegetation in the SWIR band. So if we are able to monitor the SWIR band, we are able also to detect some stress in the forest. This index was developed for fire, but we use this index also for windstorm, to detect windstorm, for example, in Italy for the Ministry of Environment and for the Ministry of Agriculture during Vaia, but also to monitor, for example, the clear-cut area in the country, in the Mediterranean area. So also anthropological disturbance. Clear cut are when people go in the forest to cut trees, but if the forest is managed sustainability, the forest will regrow. It's not a deforestation. But after I will give you more information about this. Then with the Burner ratio index, we can also calculate, for example, the burn severity. Where the fire was high severity, low severity, or where after fire there is a regrowth of vegetation. So we can also monitor after fire what's happened in the forest, what's happened, for example, if we go to plant new trees, what's happened with these new trees in the forest. FAO has developed at world level, especially for those countries that do not have some money to develop their own application, as for example, here in Europe we have Copernicus that do this for us, or in US we have NASA that gives some platform that are able to manage this data in developing countries, or in Africa, or in the south of America. They don't have this kind of money to develop their own application. So FAO decided to, in accordance with Google that developed a Google Earth Engine application, that is a cloud computing platform that gives us the possibility to manage all the repository of satellite data for scientific purposes. They developed this application, and now I'm going to show you this application and what kind of data we can find there in all the world. So these data are not just in some area, but are available everywhere in the world. Okay, I go here. Okay, this is, do you see my screen?
Yes, Francesca.
Okay, this is the HeartMap application. You need a Google account to join it, so just a Gmail account, for example, and you can choose the area of interest. For the moment, I choose Italy. Then you will zoom on the area that you want to visualize. Now here there is all the available layer that you can open to understand different things. The first one is forest. Forestry have a lot of very interesting layer. The first one is forest landscape integrities. Just clicking here, you can open the layer. And then we will have show there a map. I have also the presentation done, so we can use this one if it's not able to work. Forest landscape integrity is an index that is global consistent and give us an information about the pressure of human activities in forest. Here you have the index is from 0 to 10, and here you will see the information related to these forest landscape integrities. Here it's in Italy, but if we go, for example, in Brazil, in the Rondônia state, where there is a huge deforestation act in this moment, you will see here that the integrity index is really low, comparing here where deforestation is not enacted. While in the border of this forest, you will see that the integrity index is reducing. Since here in the border, there is an increasing of deforestation. Then we have also a layer related to the global forest change map that gives us information about the loss of forest every year. So here there is the legend. You can see that there is from 2001 until last year. Since this is the Hansen developed this map using Landsat time series, and he is able to manage this data after 1 year before the year of observation. So until now we have the ability to have just 2020. Then in next day we'll update also the 2021. Here you will have, for example, in Rondônia, every year the forest area that was cut in the state of Rondônia. And you can see that every year there is an increasing of deforestation. What is deforestation? Deforestation is when you cut and you change the land cover on that area. So if you cut trees and you replant, or the forest will regrow again, it's not deforestation, it's just a cut, it's a sustainable cut. But if you cut trees and their forest will not regrow, and there is a pasture or cropland, this is a deforestation for the definitions. Here, for example, we have in the global forest change loss map, this is Trentino and Veneto, and you can see that in 2028 and 2029, there was a huge forest lost. This was done by the windstorm in Vaia, and here you have the map of the Windthrow area. All this layer can be downloaded from here, just clicking here, and you have the ability to download the map. Here in Italy, there is not a deforestation act, but the forest area are without tree until now. So they are starting to replant the trees now. So this is the damaged area, but we know that in this area, forest will regrow again. Then we have this global forest change tree cover loss and gain that is done also by Hansen using Landsat. And here you have the tree cover loss from 2020 and 2021 and tree cover gain and stable forest. Here, for example, is the Rondonia, the area where we have deforestation, and you will see that here we have a huge amount of forest lost. And just a little part of tree cover gain that is in purple, and some stable forest here. If we go here in Trentino again, we can show the same aspect that we lost this cover by Vaia, and we have also some area where usually cut tree are where they have some sustainable forest cut with regrow. Now I'm not able to zoom the link, but you can use this application by yourself and go there to see what's happening. Then we have
10
yes?
minutes. 10 minutes.
Yes. Yeah. Then you already know the composite color the composite color that can be used to monitor some effect in the forest. Here there is Sardinia. You can see here that there is a normal composite color RGB done with the Sentinel Hub platform. And here you see that there is some gray aspect. But if we use other composite color, for example, for monitoring forest fire, this is the composite color that is called false color near red and green. You can see that here, where in last summer happened a forest fire, you are able to see the exactly area of forest fire that is in brown without any photosynthetic activities. And this is another composite colors, near and red, that you can use to map forest fire. And here there is an application that is linked with forest map that is here. Just go into image composite tools. You are able to compare two different images from the same area. Just put in here the images, the first image that you want to compare, and here the other images. They refer to the two different periods. And here you can just using this app to monitor, for example, the changes in this area that is in Sardinia, where there is a forest fire. Just clicking this link, you will go in this page. Then using the Sentinel Hub composite, you are able to monitor and to download the images to map automatically the burned area, for example. Here you already know how it's work. I know that. You just select one image post fire and one image is pre-fire, and you can customize your visualizations, and then you can download these two images just using the download tools. So you can download the false color and also the band. To calculate the NBR, you need to download the band 12 and band 8. Then you can map on QGIS the forest file, just downloading the imaging, calculate the NBR for both image, and then calculate the difference between the two NBR and reclass it according to the table that I showed you before. So just adding the raster layer of the band that you download before and after the forest fire. And then just using raster calculator, you will be able to calculate the NBR, just using band 8 as near and band 12 as will. This is the formula that you need to use here. This is the example, and you need to save the images. And you have the pre-fire NBR. Then you made the same for the post-fire, that is here. And then you can be able to calculate the difference between two NBR in order to have the result according to the table that I showed you before. So the NBR pre-file, you subtract the post-file, and you have the severity burned area, just reclassing the delta NBR. The same can be done for windstorm and strong rainfall. This is for an example in Lavazze, that is in Val di Fiemme, where we have this huge windstorm. Here are the example of to date that you can download to map automatically the windstorm. And here, for example, we have another composite color that gives us the possibility to show more in detail the area that was destroyed by the wind. That is the composite color 12, 8, and 9. Here you will see the area that were destroyed. And also you can able to calculate directly from the EO browser the NBR. From the EO browser you are able also to draw a polygon and so to download the area that you are interested in without downloading any images. So if you are able just to map the area that are wind throw, you can just use this and then you can download the KML file. This is another example in Rondonia, and this I will show you and give you the link to go into GeoLab app that we developed at University of Florence. This is the first one that you will able to see every day the new images acquired by Sentinel-2. So you are able to see what the satellite are acquiring, and another app that gives you the possibility to create a map here, a cloud composite without the cloud of a huge area. So not just in a tile of Sentinel-2, but using all the possible available images, so you can compare different area, also if they are not in the same tile. So this is an app. I will give you the link. You will just show here you select the band. You will able to calculate the composite color with a unique images all around the world. Then I think I'm finished. Yes. Yes, this is just an example on how we can monitor the regrowth of forest after a forest fire. Here is the NBR to detect the area of forest fire, but then using all available images after the fire, we are able also to monitor the regrowth of forest. This was a forest fire happened in Tuscany region in Italy, and here you will see that after 1 year we have a regrowth of forest since this was a pine forest, and so the pine are regrow in that areas. The same can be done here, for example, to monitor Vaia. We are now monitoring the regrowth of forest and the new plantation that they are doing in Trentino. And here, for example, is the monitor of an ongoing insect outbreak using the same approach that I showed you before, just downloading the images and give us the possibility to understand how the attack is going in an year. This is 1 year images. And then I finish. I hope to stay in the time.
Yes, perfectly on time. Thank you, Francesca, for your insight. Very interesting, but at the same time, practical and with a lot of example and a lot of tools that students with their teachers could use. Thank you, Francesca.
You're welcome.
Thank you. Now, guys, our experts are ready to answer your questions. If you have any curiosity, please ask. Maybe if you're more comfortable to ask questions in your language, your professor could translate them in English. That's fine with us. And professors are welcome to ask as well, or of course. So don't be shy. And as I always say to my students, there are no silly questions, but only silly replies. So I invite all the speakers to turn on their webcam, and they are ready to answer all your questions. Let's see who is the first icebreaker. Any curiosity? Any request of deeper details?
I will start in such a way that I break the ice, as a matter of fact. So, as I'm in charge of helping the school in Rovereto, I found all the presentations were very interesting, so thank you first of all, but obviously I was more interested in this last one because the topic that was chosen by the school is exactly with respect to the problems in deforestation. And yes, I want to ask you, Francesca, so first of all, thank you. And I want to ask you if you have experience also in using Sentinel-1 besides Sentinel-2, because I saw that you are using multispectral, and this is what we are, what also we taught. But are you using also Sentinel-1, so the SAR technology, in order to check the problem of deforestation in general, depending on many causes?
Yes, we can use also Sentinel-1 because in the radar we have the backscattering, and there are some studies done also in Rondonia that I show you that use Sentinel-1 to detect deforestation, especially because we don't have the problem with the SAR related to cloud cover that usually in tropical forest could be a problem because there is foggy days because of the environment. So yes, we can use also SAR data. In Italy, or for example in the Alpine regions, we have some important, we cannot use, for example, SAR. We test the SAR data, but we had some problem more than, for example, the use of optical data in the spring and summer times. Because of the backscattering of snow and something like this, we are not able also in the winter time to detect, for example, Vaya was happening in October. We test immediately SAR data because of the cloud cover in that area, but there's no persist in different times in different areas. So in a small area, we can create some classification there, but if we want to manage all the data together for all the Alps arc, it was easier to use the multispectral data comparing to the backscattering. But that, yes, in tropical forest, they use also SAR data to map the biomass and the growing stock volume of the forest, because they are, with the backscattering, we are also able to calculate the height of trees comparing to the Sentinel-2 data. Yes. Now we have also a satellite, not a satellite because it is on the space agency that is called JEDI, that is a LiDAR, sensor that give us the possibility to understand the tree height. Now they are working, the NASA is working to have some calibration with LiDAR data acquired by airplane. So we hope that this satellite will be, this sensor on the space agency will become a satellite that give us also the possibility to understand the height of tree, and so the carbon stock, the biomass, and the growing stock.
Okay, thank you.
Any questions from students? Any curiosity? May I ask maybe to Simone, what you showed, what we have shown you before. I guess, well, I know, but students may not. So I guess that all these products can be downloaded free of charge from the European Union site, of the Copernicus Emergency Service. So maybe you can just in 1 minute say to our students how or where they can download this data and they can use free of charge all this data for their project. Just a few words, 1 minute.
Yes, as you say correctly, true. For Copernicus Emergency Management Service, but for all the services except for the security service, the products are distributed on public and full and open access. So every product can be downloaded and analyzed by the public. So in particular for the Copernicus Emergency Management Service, there is a specific portal, which is emergency, which URL is emergency.copernicus.eu/mapping. You will find it in my slides, but it can be easily found on Google by typing Emergency Management Service Mapping. And there you will see lists of past activations defined by a code for each of the activation. And then by following the links, you can have the page for downloading specific products. So it's
yes,
easy with just a web browser.
Maybe it is important to mention that end users, I mean normal end users, as students cannot ask the European Commission to activate an acquisition, but they can browse free of charge all the archives, so all past activation. That's correct?
Correct. It's correct, of course. For activating the service, this is a very important task. So it can be done only by authorized users from the member states of the European Union.
So that means mainly civil protection.
Exactly, mainly civil protections body or contingency agencies in general.
Thank you, Simone. Any other curiosity or question?
Marco, if I may.
Yes.
If I may, just before leaving to you the floor again for the conclusion of the event, I would like just to say thanks again to you and to all the speakers for the great webinar of today. I find it really very interesting and I think helpful and useful for the GIS outputs that our schools will going to develop. So thank you very much again. And I will just remind that, of course, the webinar has been recorded, so all of you can also consult the recording of the webinar during the next days in case you have you want to have a little bit more information again on what we have said. And I will also remind that in the chat you will find a link for the list of participant template. So I invite especially the teachers to fill in the form. It's just a document for internal purposes, but it's important for the reporting of the activity.